Hello everyone, I am Mr. Shahad P, Assistant Professor in the Department of Artificial Intelligence, Madanapalle Institute of Technology and Science. And today in my session, I am going to discuss about one of the important unsupervised clustering algorithm called K-means algorithm. So here we are discussing the contents like what is a K-means clustering algorithm, an introduction about that, and the important point while calculating or making a cluster, we need to know which are very similar points. So for that, we are using different distance formulas. That also we are discussing here. Another challenge we are facing in K-means clustering is the K value. How we are finding that K value is also discussing here in this session. That is called elbow method. Then we will go to the K-means algorithm, a small algorithm, how it is working, and the different steps. That is also discussing here. And finally, we'll go with an example problem, very small example problem with the least number of iterations, like three iterations we'll go through. And I will explain how it is working in Python and machine learning code. So these things we are going to discuss in today's session. So let's move to the introduction part. As I told, it's an unsupervised clustering algorithm. Generally, clustering is unsupervised method. It means we are not giving any labels to the data that we are collecting. So here also, K-means clustering algorithm also receives the data which is not labeled. And in this case, we are choosing that K value arbitrarily. That K in the sense, the senders of clusters. Cluster sender in the sense, suppose we are having some 50 students in the class, we will make them clusters as three clusters, maybe like uh, highly performing students and average students and below average students as three clusters. So for these three clusters, sometimes we are keeping some references, or we can say sender one or a sample person to represent that particular group. We are choosing randomly, right? Same way, we are also choosing k in a random method. There are different methods to choose that k, but here we are choosing it arbitrarily. And now we are calculating the distance between different points to each and every clusters, and we are assigning that clusters points into the clusters, corresponding clusters. Then we will change that centroid on the basis of average values. Then again, with that newly formed centroids, we will calculate distance to each and every points. Again, we will uh, uh, classify a cluster. We will cluster each points into different cluster centers, and this process will repeat until it converges. So that entire process we are going to explain in detail. Here we have many challenges, especially while dealing with the different kinds of data. We are in confusion. We don't know which type of distance metric will be apt for a particular application. So there we will be having some issues. So how to define the similarity? What kind of similarity measure we can choose? That is one challenge we are facing here. Again, we have some challenges in terms of the number of iterations that we require to conduct or require to get a quality cluster. So the quality cluster in the sense, we know that a cluster is having more clarity if all points in these clusters are easily identified from the other points which are falling under different clusters. That means the intercluster distance should be maximum and intra-cluster distance should be minimum. That means the points distance between the centroid and the points in that cluster should be minimum, and distance between centroids of different clusters should be maximum. For that measurement and all, we are having different uh, measuring methods like Silhouette score we are using, then WCSS are also we are using. So that methods are there, but still now in this session we are discussing about the method K means algorithm, how it is working and all. So that is the basic of K means clustering. Now we will go to the first prerequisite. Actually, I should say it is a prerequisite. We already studied these distance formulas, and many other distance formulas are also existing. For the time being, we are choosing only four and just giving a glance over these different matrices or distance formulas. And most familiar and commonly using distance formula is Euclidean distance. Say here we have 2 points, x1 comma y1 and x2 comma y2. The distance can be calculated by the equation d is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Clear? It's already well-known equation. But in this problem, I opted Manhattan distance, and it is a modular distance based equation, and it is calculated by the formula modulus of x1 minus x2 plus y1 minus s2 y1 minus y2 is the distance. So in some cases, we are using Hamming distances that is used to measure the distance by counting the number of changes in the bits, and we are noting that number of changes. That is treating like a distance. Then cosine similarity, another method of finding similarity between 2 points, that is also available. So in this session, we are solving the problem by using the Manhattan distance equation. Now let's move into another slide that is related to a prerequisite. While we are starting to cluster, as I told, if you want to classify cluster the students or 100 students into 4 clusters or 3 clusters or 2 clusters, it is up to you or your requirement. We are clustering the points. So if we are not a domain expert, we will be in confusion what we should set k value. In these cases, we are using a method called elbow method. So in this elbow method, wherever this elbow point comes, we draw a line just down to the elbow point. Here in this case, just down that elbow point, you can see the point 3 is falling under that elbow. So we are choosing that 3 as optimal number of cluster for this particular set of problem. So it is up to the problem and up to your requirement. Normally we are using this elbow method, or people will use arbitrarily some k values. So this is most commonly used method for fixing the number of clusters, or final output should contain how many clusters and what should be the optimal value. If you are in a dilemma, you can use this method. Now we will move to the k-means algorithm. How this problem works, basically what it is happening in each and every step. That's what we are discussing here, step by step. So first step, as I discussed, here we are randomly selecting k cluster centers. That k is already fixed, an optimal k, which we fixed by using elbow method. Now we are clear that we want to form k clusters, and that k clusters should contain cluster center, and that cluster centers are marked as v1, v2, v3, etc. up to the count. Here it is like v1 comma v2 comma v3 caps. These three we can treat it like a centroid or cluster centers. Now the next step, step 2, we will calculate distance between each data point. Assume 50 students means 50 data points. In this problem, I will take only 8 points. So there it will be 8 points. The distance between V1 cap, V2 cap and V3 cap with each and every xi cap, here it is represented as xi cap, we are calculating distance between each v's and each xi's, and we are noting it down in a table. After that, for each j 1 to n, he assigned the data point xj to the cluster center vj. That means we find some xi or xj, we say xj, which is very close to one of the VIs. I'm telling again, we find some xj, which is, we find each and every xj which is very close to vi. V1, V2, V3 is there, and x is from 1 to n. So first xi is very close to V1, V2 or V3. We choose that vi which is having minimum distance, and we assign that point xj into that particular vi. So first thing, after selecting cluster centers, we are calculating distance of each point into each and every cluster centers. Then we are choosing the minimal distance of each and every point and assigning that point into the clusters. Then finally, after finishing all these 8 points and calculating minimum distance to each and every cluster centers, we will group them into 3 clusters or k clusters. So 4 clusters or 3 clusters we formed. Now we are going to change these cluster centers vi cap. How we are changing it? It is by using the formula 1 by ci, and in the bracket xi1 or xi2, whatever we are assigned into that particular vi, and all these points values added together, and how many points are there, we are dividing with that number. Now we will get another cluster centers. If it is not changing, no problem, but mostly it will change in first iteration, second iteration, before it is converging. So we got new cluster centers, vi1 or v1, v2, v3. All these three may be changed or one may be changed. Anyway, we got cluster centers again. The same process from step 2 onwards. Cluster center has been changed. Now we are again calculating distance of each point into these newly formed cluster centers. Right. Cluster centers has changed. So definitely distance between the point and cluster centers will be changed. We are calculating that distance. Then again the assignment process will happen. Again cluster centers will be changed. The same process we will repeat in a loop till it converges. So convergence criteria we have to fix. Convergence in the sense, assume that in the second step we assigned all 8 points into 3 different clusters. In the third step, the same thing happens. All the points we assigned it to the clusters in the second step is repeating in the same case when we are doing the same iteration in third time, or in the fourth time also it is coming like same thing. It means it converges. No need to go for further iterations. So that condition we can set either by convergence or by manually we can fix it. Up to the 3 iteration we can stop. Whatever we are getting, we'll proceed with that. If you are still facing some issue with the issue with performances, like its metrics, we will evaluate performance of this k-means algorithm. Metrics we will evaluate. If we are not satisfied, then we can go for further iterations. So that's what we are doing in this k-means algorithm. Very simple algorithm. Very few steps are there. The only thing is we have to repeat the process many times. So straight away we'll go to an example, simple example problem to understand the basic working of k-means clustering. It may not be that much simple if we are going with real-time data. Maybe more features will be there. Here we are taking only numerical data, and we are taking only 8 points with the assumption that we want to form 3 clusters. So k equal to 3 is what we are assigned here. So points I'm reading again. First time A1 to A2, A1 to A8 we are assigned it as points for the better understanding. So A1 point is 2 comma 10, x comma y is 2 comma 10, x1 is 2, y1 is 10. A2 is 2 comma 5, A3 comma 4, A4 5 comma 8, A5 7 comma 5, A6 6 comma 4, and A7 1 comma 8, A8 4 comma 9. I just named it as A1 to A8. Now in first iteration, we have to choose cluster centers. I told you, right? Here I opted arbitrarily fixing 3 cluster centers. I marked it as cluster center C1, cluster center C2 and C3. C1 is the point A1, that is 2 comma 10. C2 is point 5 comma 8, which is F4. Yeah, F4. Then cluster center C3 is assigned as 1 comma 2, that is A7. Okay, we fixed K as 3 and cluster centers arbitrarily we choose C1, C2, C3. Second step is over. Now we want to calculate distance between each point and cluster centers. So here we are forming it as a matrix for easiness. We form a matrix where columns are cluster centers and rows are each points. So first point we will clusters and we'll calculate the distance of each point with the cluster centers. So C1 cluster center, its value is 2 comma 10. We calculate distance from C1 to A1, A2, A3, A4, A5, A6, A7 and 8. So first one 2 comma 10 to 2 comma 10. We are using Manhattan distance. Manhattan distance, it is very easy. It is distance D is equal to modulus of x2 minus x1 plus y2 minus y1. Very simple. So here it is 2 minus 2 plus 10 minus 10 equal to 0. Right. Now second C1 to A2. C1 is 2 comma 10 and A2 is 2 comma 5. So distance is 2 minus 2, modulus of 2 minus 2 plus modulus of 10 minus 5. So it is 0 plus 5 equal to 5. Similarly, A4, just one more time I am calculating. A4 means modulus of 8 minus 2 plus 4 minus 10. It is Manhattan distance and we are using modulus. So no need to worry about this 8 minus 2 or 2 minus 8. Both will result in same value. So 8 minus 2 plus modulus of 8 minus 2 plus modulus of 4 minus 10. So 6 plus 6 equal to 12. So this way we calculate distance between C1 to A4, C1 to A5, C1 to A6, then C1 to A7, C1 to A8. Done. So that part is over. First column we filled. Now we have to calculate distance of each and every point with the cluster center C2. Its value is 5 comma 8. So 5 comma 8 and 2 comma 10. The distance is modulus of 5 minus 2, that is equal plus modulus of 10 minus 8. So 3 plus 2 equal to 5. Then distance of C2 to A2, 2 comma 5 comma 5 comma 8, that is equal to 3 plus 3, 6. Simple. Same way Manhattan distance we are calculating. Then 7, next A4 and C2, it is F4 and same point, so it is 0. Then A5 and C2, F4 and C2, it is already discussed 0. Then A5 and C2, it will comes to 0. A not 0, it is 5 because A5 is 7 comma 5. 7 minus 5 plus 8 minus 5, that is equal to 2 plus 3 equal to 5. Then A6 to C2, A6 to C2 will be 5, A7 to C2 will be 10 and A to C2 will be 2. Now distance between cluster center C2 and all the points are calculated and we tabulated it in column number 2 or C2 column. Now distance with cluster point 3, centroid is fixed as C3 and its value is 1 comma 2. We are calculating distance between C3 to A1, C3 to A2, C3 to A3, like that we will calculate for all the points. Now first one C1, C3 to A1, 2 comma 10 and 1 comma 2. So it is equal to modulus of 2 minus 1 plus modulus of 10 minus 2. So it is 1 plus 8 equal to 9. Very simple. The same way we will calculate all the distances. The task is over. I hope you understand. Very simple Manhattan distance we opted. If you are using uh, other distance formulas like Euclidean distance, again you can calculate. For the easiness of understanding the concept, I opted Manhattan distance. Now, very important thing is next column. Here I wrote it like cluster. You can see right. Last column cluster. There we are assigning each point into the closest centroid. See, first row we are taking. Now we are looking row wise. in the first row, you have to check which is the smallest number. 0 is there, 5 is there, 9 is there. So 0 is the least number, right? And that is coming under cluster center C1. It is coming with cluster number C1. So we are assigning point A1 to the cluster center C1. Okay. Same. Second row. In second row, you can see that the values are 5, 6, 4, and among that the least number is 4, which is coming under C3. So we are assigning the point A2 into C3. Now in third row, same way we can see that the least number is 7, which is coming under C2. So we are assigning to cluster center C2, right? Very easy task. So we can proceed in the same way. If we see A4, the least number is 0, which is coming under cluster 2. So assign to C2. Then A5, it is least number is 5 and is in under C2. So assign to C2. Then A6 also, least number is 5, coming under C2. Then A7, the least number is 0, which is coming under C3. So we assign to C3, cluster C3. And finally, A8, the least number is 2, that is under C2. So points are assigned to different clusters. Each and every point is assigned to any of these three clusters, centroids, which is very close to the centroid will be assigned. Now that task, tabulation task is over. Now we have to go for next step in the algorithm, and the next step is changing the centroids or cluster centers. We have to alter. So for the easiness task, we are making it cluster. Wherever we wrote C1, that we marked it as a cluster 1. Only one C1 was there, that is 2, 10. Then you can see that C2, cluster center 2, we can see 5 times. 8, 4, 5, 8, 7, 2, 6, 4, 4, 9. All these are coming under cluster 2 C2. Now C3 you can see 2 times, 2, 5 and 1, 2. That we can write. That is for the easiness of mathematical calculation. Now we are changing centroids or cluster center. C1 we are going to change. Earlier we have 2, 10. Here only 1 point, so no need to change. But see how you change C2. C2, see, there are 5 points. We are taking all its x components. 8 is there, 5 is there, 7 is there, 6 is there, 4 is there. We are adding all these things together and we are dividing with the count. 5 points are there, so we are dividing by 5. Then y components. 4 is there, 8 is there, 5 is there, 4 is there, and 9 is there, right? All y components we have selected and we added together and divide by total count, that is 5. Now its result will be 8 plus 5 plus 7 plus 6 plus 4, that is equal to 10 plus 15 plus 5, that is 30 by 5. So it is equal to 6. Same way, y side also 30 by 6, it is equal to 30 by 5 is equal to 6. So anyway, the centroid is changed and that becomes 6, 6. Now centroid 3, only 2 points. So we have to change centroid 3 by considering 2 points. X values are 2, 1 and y values are 5, 2 and divide by 2. So 2 plus 1 by 2, 1.5 and 7 by 2, 3.5. Centers are changed. Now if we do these calculations, the same method we have to continue again for n number of iterations. Here we are doing it for 3 iterations only. If you are doing it fourth time, you can see that it is converged. Same thing will happen again. Even though if you are not getting same result, you can stop at a point. As I told at the beginning, you can change if it is really required. Whenever the performance of this particular algorithm falls under required performance level, you can think of increasing the number of iterations. So here we are doing it for 3 times. For the time being, we are giving a glance to the next round, how we changed this algorithm, change this table. Okay, same table only. The only difference is where we changed. You have to note it down. Cluster C1 have not changed, and points definitely it will not change. The points will be points only. The values will be same only. It won't change. The only changes will happen to the cluster centers. So definitely in cluster C1, that column, It is not required to alter anything. Now see cluster C2, second column, its centroid is changed or cluster centers are changed 6 comma 6. It becomes 6 comma 6. Now we have to calculate distance of C2 with all the points A1 to A8. Same distance formula we are using, Manhattan distance. Now we fill this value by calculating this distance. We got 8, 5, 4, 3, 2, 2, 9, 5. The all column, all rows we filled. And again C3 also, this cluster center is changed. Now it become 1 comma 5 comma 3 comma 5. So we have to calculate again distance between C3 to A1, A2, A3, A4, A5, A6, A7 and A8. We calculated this distance. We got 7.2, 7.8, 7.5 and 2.8. All these values we calculated. Again the process we are repeating column wise, row wise. First row, the least number, again it is 0 only. So that is C1 cluster, already it is assigned. Same way it is assigned to C1 again. Now A2. A2 here it is assigned to C3. Then A2 is assigned to C3. Then A3 you can see this least number is 4, that is assigned to C2 cluster. Then A4 the least number is C2 assigned to C2. F5 the least number is 2 and it is assigned again C2. So A6 again assigned to C2. A7 it is assigned to C3, no change. Finally you can see the last point A8. When the cluster center is changed, earlier this point is assigned to C2. Now see, the distance between A8 and C1 has not changed, but the distance between A8 and C2 is changed. It becomes 5, and C3 and A8 it become 8. In this row, you can see that the least number is 3, right? Least number is 3. So this time, after second iteration, a change has happened. The point A8 is assigned to cluster center C1. Okay, so that is the major change we can see in this particular iteration. So we can see the changes. Cluster 1 is changed to 2 points. Earlier it was 2 comma 10 only. Now it is one more point 4 comma 9. At the same time, cluster 2 also changed. Earlier it is having 5 points. Now it is only 4 points. Cluster 3, no change. The points are 2 comma 5 and 1 comma 2 only. No changes. But the thing is, while we are calculating centroid or cluster centers, the centers will be affected, especially centroid of 1 and centroid 2 will be affected. 3 will remain same. Now centroid 1 will change by this particular value. You can see it. We are taking the values 2 and 4, x1 comma x2, x1 plus x2 by 2, then y1 plus y2 by 2, 10 plus 9 by 2. It will become 3 and 9.5. So centroid of first centroid is changed. Same way, centroid 2. Earlier it was 5, now it is 4. And 6 comma 6 is changed to 7 comma 5.25. So that is also changed. Centroid 3 have no changes. So we have done the second step, second iteration. Now we are moving for one more iteration, third iteration. See how this third iteration looks like. In third iteration, changes happened at C1 and C2. The remaining C3 have not changed. So we no need to worry about the column C3, but we have to calculate the distance between C1 to all the points and C2 to all the points. So we'll calculate it. We got the values like C1 to A1 as 1.5, C1 to A2 5.5. Same way 10.5, 3.5, 8.5, 8.5, 9.5, 1.5. So all these values we are calculated by using Manhattan distance. And C2 again, we calculated the same formula we used. The calculation steps are all same. We got the values like this. Okay. Now, one more time, we are assigning each points into the nearest cluster centers. Now, A1 point, we can see the least value. Now, earlier it was 0. Now it is 1.5, but still it is the least value. So it is going to the C1 point only, cluster center C1 only. Now, A2. A2 means in that row you can see the list number is 2. So list number is 2 means we are assigning that point to C3. Earlier also it is C3 only. Now A3, the list number is 2.25, it is assigned to C2. Now C point A4, how it is changed? Earlier it was with C2, now the least value is 3.5. that is very close to the cluster center C1. So we have to assign the point A4 into the cluster center C1. Right. So C1 got one more point in the cluster. We got one more point. A5, the list number is 0.25, that is C2, and A6, the list number is 2.25, that is under C2, and A7, the list number is 2, that is under C3, and now the last point, the list number is 1.5, and it is C1. So you can see the rightmost column, 1, 2, 3. 3 C1s are there, 2 C3s are there, and 3 C2s are there. So 3 C1, 3 C2, and 2 C3 points. Total 8 points are clustered in that way. So you can again calculate the centroids. As I told, if you want to repeat means you can repeat, you can check it. Now I am stopping this 3 iteration. So after this 3 iteration, the cluster points or the points under the cluster 1 are 2 comma 10, 4 comma 9, and 5 comma 8 are falling under cluster 1. And under cluster 2, 8 comma 4, 7 comma 5, and 6 comma 4 are clustered. In cluster 3, 2 comma 5 and 1 comma 2 gathered together. So it form another cluster. So 3 clusters are formed. We again calculated centroids and we got the values. 3.67 comma 9 as a centroid value. Then for centroid 2, we got 7 comma 4.33, and centroid 3 we got 1.5 comma 3 comma 5. These three are new centroids. So this is what the final result, and now we have to show in Python how we can do it and what will be the final result. So actually this result will be very clear if you draw a graph that I will show you next with the Python code. So this is all about the final result. We clustered all the 8 points into 3 clusters, cluster 1, cluster 2, and cluster 3, and the points are given like this. That is the final result. Now it is all about visualizations that we will do with the Python code. So we will go for uh, Python code. So we are not doing a scratch code. We are utilizing the function which is already available in different Python libraries. So this sklearn contains the k-means algorithm. So we are just importing that with the help of NumPy array. We are giving the points as input. All these points are given as inputs, which is named as a list points. Then we are initializing the k-means clustering algorithm. The variable we use is k-means only. K-means equal to k-means of n number of clusters. Initialization of k value, it is given as 3, and we are giving random state as 2. So with these points we are fitting this k-means algorithm. In real life, we are not doing like this. Why? Because it is only 8 points. That is for understanding of the problem. But when we are dealing with real-time data or doing some projects, we will get a huge amount of data and we have to go for many different stages of machine learning process. We may be required some kind of label encoding or different like feature extractions, many things we have to do. Here we directly use that points and we are fitting these points into this particular k-means algorithm. We fit that points and we assign labels for each and every points in that particular list. So once we got the labels, we form the cluster centers, and for that we are using k-means dot cluster underscore centers underscore. So all these cluster centers will be stored in the variable cluster center, and now we are printing the result. Cluster points is equal to list of zip of points comma labels, all the points along with its assigned labels we will store in the cluster points, and we will print these cluster points along with the cluster centers. Cluster centers already we collected, and we are printing all these things together. Whatever we done in the example problem, we are showing it as Python code. 2 comma 10 falls under 1, center cluster center 1. 2 comma 5 falls under 2, cluster number 2. 8 comma 4 goes to 0, Then each and every point along with its cluster centers are printed here. And finally, the last value of cluster centers is also printed here. We also got the same values 3.66, 9. The order is different, but same value we also got by mathematical calculations for 3 iterations. 7 comma 4.33, 3 comma 3.66 comma 9, 1.5 comma 3.5. The same result we can see by running this simple Python code. So hope you understand this code. I just want to convey you the very simple methods are there in Python. Once you learn the concept, you can go for it. You can learn it uh, with Google Colab. You can run this code. Now it is just for plotting purpose. By using matplotlib, we are plotting each and every point with the colors. So in this graph, you can see 3 clusters. There you can see one big X marks. That nothing but it points, it represents cluster centers. It's not a point, it is cluster center. Points you can see uh, total 8 points, 3 red points and 3 green points and 2 blue points. So these 3 colors represent the clusters and the cross marks represent cluster centers. So from this figure, it is very clear that they are forming 3 clusters, cluster 1, cluster 2, cluster 3. One contains 3 points, another contains 3 points, and another contains 2 points. So this is for the easy understanding of the final result. So this is about k-means clustering, and thank you all for watching this video.